Welcome. Yet another YouTube video on face masks, in particular 3D printing of face masks, and I'm going to offer a slightly different approach to probably what's out there. Just a bit of background. These are your standard N95 masks. They filter down to the correct particle size, but they're not a long-term mask. They're semi-throwawayable. And cloth masks, which we're seeing lots of now, they're very good for the right application. They don't really filter down to the particle size that we'd like, but they have the advantage in that they're washable and they're reusable. So with that in mind, I wanted to print something that used a fairly long-term cartridge. And when I went out to my workshop, I've got quite a few. Well, I use a double cartridge respirator, and they use these replaceable 70 mil cartridges. And the life on these is, well, in an industrial environment, they say a life is about 3 months. In a normal non-industrial environment, just outside in ambient air, these probably would last much, much longer than that. In fact, they're stamped for a 5-year life. So in looking at 3D printing these, there's numerous designs out there, and it didn't take that long to come up with a design which could accommodate the filter. That wasn't too hard, but what was a problem was this is printed in PLA, and it's a very rigid material, and it's very, very uncomfortable in the face. In fact, after just a few minutes of wearing this, I ended up, having cut marks on the bridge of my nose. It's just too uncomfortable. So there's lots of solutions out there in the 3D printing community to solve that, and it ranges from putting neoprene lips around these, using adhesive. One lovely design involves making a mating part, which this can sit into, and a silicon bead is essentially potted onto the bottom with a release agent. So when you lift it out of the other half of the mold, you end up with this silicon seal. So I guess I didn't want to really go that way. I just wanted to be able to push a button and print something. So I started looking at flexible materials, in particular TPU. And I had some TPU, which I found was cheap TPU. I just couldn't print the stuff. So after doing a lot of research into printing flexibles, I soon discovered that you needed a Swiss Micro or a direct drive type extruder. I'm using a Corelity CR10 Mini, and it uses a standard extruder with a Bowden tube. And you simply can't push flexible filaments down the Bowden tube and get any decent results, if it works at all. So the solution was to put the Micro Swiss direct drive extruder on, buy some decent TPU filament, and give it a go. And I ended up printing a slightly modified version from the PLA one. Looks a bit longer, but what I did was I incorporated a bit which could have the cartridge pop in, so that it would provide the lip for the cartridge as well. So the beauty of this is we now we have something which is flexible. So it's much, much more comfortable to wear. The other part of the design criteria is I didn't want to have something as bulky as a 2 canister respirator. So if you look at a normal N95 mask, for example, on my face it would look like this. So with this mask, it's not all that much bigger, but it's totally reusable and washable. And the cartridge itself, the black side normally goes to the inside the mask on these. Just pops in inside and snaps into place, and that's it. So The other part is the little clips for the adjustable straps, and these I just printed in PLA, and I'll put a link to them and the STL file on Thingiverse for all of this stuff, and that's using 6.8 millimeter elastic. So a couple of questions about this. You'll notice, people that are familiar with masks will notice that there's no exhaust valve. So all industrial respirators would use something like that, and these would normally be incorporated in the mask, and it allows for the air to go in through the filter and be exhausted through the vent. It's a one-way valve. I did some research into this, and for this type of application where it's not a sports type thing, you're not heavy breathing, if you're just using it for general purposes in the community, then there really doesn't appear to be any need for an exhaust valve, and there's no real worry about CO2 buildup in these. This is still a very open material, if you like, for breathing in and out. And I'll put a link to some research which may be of interest if that's a concern to you. The other thing is we all have different face shapes. So this material, and obviously the old PLA or the standard PLA, they have the ability to be actually reshaped using a heat gun. There's a bit of experience you need to reshape it, but you just have to get it at the right temperature, not too hot, and you can actually alter the shapes of these wings to suit your face. But the amount of flexibility in these, a bit hard to see in a video, accommodates most, I would think, accommodates most faces anyway, most face shapes. The other thing worth mentioning is these cartridges, the 70 mil cartridges. They're fairly common. These just come from my local hardware in Australia. It's Bunnings, and they're about, I think, as I said before, around $17 maybe, probably a pair these days. But there are newer designs. It's all for marketing, so they can change masks, I'm sure. And the new ones, a lot of them are clip-on type, bayonet type fittings, and there's some out there which actually are not round anymore. They're more of a rectangular shape. Those are probably becoming more common. These are still common in the agricultural area. The mask itself, the STL filter, the STL file will be in the link below, and if you go to Thingiverse, you can actually download the file and import it and make all the necessary modifications that would suit a different style of filter. I think that's probably all I need to say. I guess in terms of particle size, these are P2. They meet the Australian standard for P2. They come with the little tick of approval thing, and they filter down to 0.0003 millimeter particle sizes. So that should be adequate for the task. Okay, that's it.